Two companies can use the same AI model and get very different results. The difference is often not the algorithm, it's the data. As AI tools become more accessible, many assume the competitive edge lies in model sophistication. But increasingly, the real advantage may belong to organizations that control richer, more proprietary data ecosystems. Consider two retail companies using the same demand forecasting system. Both license a similar machine learning model. Both have access to public economic indicators and historical sales trends. But one company has detailed, structured data on customer behavior across online and in-store channels, real-time inventory flows, and years of internal experimentation results. The other relies mostly on generic transaction logs. The model is similar, the outcomes are not. The gap emerges from the depth and structure of the data feeding the system. This pattern is visible across industries. In healthcare, AI tools trained on large and diverse patient datasets can detect patterns more reliably than systems trained on smaller or less representative samples. In logistics, firms with granular tracking data across supply chains can optimize routes and anticipate disruptions more effectively. In finance, institutions with long histories of transactional behavior and internal risk assessments can refine credit models beyond what public data allows. The system may be widely available, the input is not. There is a common narrative that AI democratizes capability. Cloud platforms provide powerful models to startups and small teams. Open source frameworks make advanced techniques accessible. In many respects, this lowers barriers to entry. But democratized models do not eliminate differences in data access. If everyone can use similar tools, then proprietary datasets become the distinguishing factor. Data ecosystems are not just about volume. They include how data is collected, structured, cleaned, and integrated across functions. Organizations that have invested in consistent data practices over time often find it easier to deploy AI effectively. Those without that infrastructure may struggle, even with access to advanced models. The advantage is cumulative. A credible counterargument is that model innovation can offset data limitations. Transfer learning, synthetic data generation, and general-purpose foundation models can reduce dependence on narrow proprietary datasets. In some cases, broad pre-trained models perform well even with limited domain-specific data. This has allowed smaller players to compete in areas that once required vast resources. The playing field has shifted, but it is not fully leveled. Large organizations often combine foundation models with proprietary fine-tuning. They feed internal performance metrics, user behavior logs, and contextual business data into the system. Over time, their models become better aligned with their specific environment. Competitors without similar data cannot replicate that refinement easily. The advantage compounds quietly. There is also a feedback effect. Organizations with better data generate better predictions. Better predictions improve operations. Improved operations produce more structured data. This creates a loop. As performance improves, so does the quality of future inputs. Firms lacking strong data pipelines may find it difficult to enter this cycle. Another dimension involves platform ecosystems. Companies that operate widely used services, search engines, marketplaces, operating systems, collect interaction data at massive scale. This data supports continuous model improvement. Smaller organizations using these platforms contribute data, but they do not necessarily gain equivalent access to aggregated insights. The platform's advantage grows through participation. Control over data becomes strategic leverage. This dynamic has broader economic implications. If competitive gaps are driven less by algorithmic breakthroughs and more by data control, then market concentration may intensify around firms with extensive data assets. Innovation may still occur, but it could depend increasingly on partnerships or data sharing agreements. Access becomes negotiated rather than assumed. However, this trajectory is not predetermined. Data portability regulations, open data initiatives, and collaborative research networks can distribute benefits more widely. Organizations can invest in internal data governance to reduce fragmentation. Strategic decisions about what data to collect and how to structure it can influence long-term competitiveness. The divide is influenced by policy and management choices, not only by technology. For individuals and smaller firms, the implication is subtle. Mastering AI tools may not be enough. Understanding data pipelines, governance, and integration becomes increasingly important. The competitive edge may lie less in prompt design and more in how information flows across systems. As AI systems continue to improve, attention often focuses on model size or computational power. But models operate on what they are given. If the inputs differ, the outputs will diverge. The real asymmetry may not be in who uses AI, but in who controls the underlying data environment. Recognizing this shifts the conversation. The question becomes not only which model is better, but whose data makes it better. Because in a world where algorithms are widely accessible, data ecosystems may define the next competitive frontier.